So the exercise 2 kinetic model of matter and the doubts related to this exercise, first is page 7. Page 7, question 9b1. A balloon travel upward through the atmosphere, the volume of the helium increased. The temperature of a helium remained constant. State an equation that relate the volume and pressure. So how we can relate the volume and pressure? We have the formula PV is equals to K, you can also say, or you can also say P1 V1 equals to P2 V2. Because when two quantities are inversely proportional, the product is constant. So you can say P is equals to K over V. Or you can also say P into V is equals to K. As the two quantities are inversely proportional, the product will be constant. Or you can also say P1 V1 equals P2 V2. Page. Whenever two quantities are inversely proportional, the product is always a constant. That's a rule in maths that when you are increasing a pressure, the volume will decrease. So when you take a product, because when you multiply these two quantities, you will always get a fixed number. If I say pressure is 100 and the volume is say 2, so 100 multiplied by 2, that's 200. If I increase the pressure, like pressure is 200, the volume will decrease, but the product, when I multiply, I'll get the same answer. So in maths, whenever two quantities are inversely proportional to each other, the product of the two quantities is always constant. And when two quantities are directly proportional, their ratio is constant. So that's always a rule that two quantities directly proportional, ratio constant, inversely proportional, the product will be constant. The next is page 8b2, 9b2. So in 9b2, use a figure, determine the height at which the volume of the helium balloon is twice the volume on the ground. So this was there at the ground. When it was on the ground, because like the pressure was, this balloon was changed, like we released the balloon from the ground. So this height was 0. So this is at the ground. When it was at the ground, the pressure was 100 kilopascal. The question is, what is the volume? The question is, determine the height at which the volume of the helium in the balloon is twice as the volume on the ground. So if the volume increases, what happened to pressure? The pressure will decrease. Like as this balloon will rise, its volume will increase and the pressure decreases. So what will happen if the volume is double? If the volume is multiplied by 2, what happened to the pressure? The pressure will be divided by 2. The pressure will be half. So the question is, when the volume become double, at what height the volume will become double? So when the volume will become double, the pressure will be half. So if the original pressure was 100, what is half of 100? Half of 100 is 50. So we'll draw a line. When the pressure is 50, we'll draw a line and find its height. So it is about like each box here. When you check the y-axis, each box is representing like 200. So it is 3,800 meter. So what happened, like a balloon which is released from the ground. So on the ground, the pressure was 100 kilopascal. The question is, when the balloon volume become double, at what height the balloon volume will become double? So if the volume will become double, it means the pressure will be half. So if it was 100, it will be 50. So when 100 become 50, how much height has changed? It was on the ground and now it is at 3,800 meter above the ground. The next question is page 10, question 11. B2 and 12B2. Okay. 12B. So 11B, on a figure 4.2, arrangement of atom in crystalline solid and arrangement of atom in a gas. So In a crystalline solid, what you have to do, you have to draw the particles, atoms tightly packed together, a lattice you have to draw. Where in a gas, the particles should be away from each other. The next one, describe the motion of atom in solid. Like particles can only vibrate about fixed position. A sculpture makes a statue from a block of a crystalline rock using a cutting tool. Explain why he must apply a large force to the tool to remove a small pieces of rocks. So what is the reason? Like basically what we have to do when we want to deform a solid or when we want to break down a solid, we have to separate like force is needed to separate the ions from each other, the particles from each other. So the main idea is that like what happened, we need a force to separate the particles or ions from each other. So why, and it's of 2 marks. So because in a solid, the answer when you write here, you'll mention in solid, the particles are tightly packed together. 1 mark for that. And when these particles are tightly packed together, what you have to do, you need a large force is needed to separate the particles from each other. That's how, like example, using a cutting tool, we can just cut this piece of rock or a crystalline rock. So to separate these ions or particles from each other, we need a large force. So particles are tightly packed together. That's why we need a large force to separate them. A helium-filled balloon in a room of a house which suddenly burst. State and explain in terms of atom what happened to helium from a balloon after the balloon has burst. So what will happen? Basically, when like there is a room and in the room the helium balloon has burst. So if this is representing a room and this is a balloon, there are particles here. When the balloon will burst, so there is no, like now it will take or occupy the space of the room. So when it occupies the space of the room, what will happen? The particles will move away from each other. Or when these particles diffuse from move from higher concentration to another from high concentration to a lower concentration, what we call that as a diffusion. So diffusion will happen or diffusion will occur. And what happened to the density? What happened to a density? Because first in a small space, same particle, but in a large space. So the second mark is for density. What happened to the density of the helium? Is it increase or decrease? The volume has increased. The number of the particle does not change. If the volume increase, what happened to density? That will
Decreases.
decrease. So density will decrease. So 1 mark is for mentioning as it will diffuse the density. 1 mark is for diffusion. 1 mark is for the density. Then 12 part B, a student places a thermometer near a bottom of a beaker. Electric fan continue to blow air the top of a beaker, and after some time, student observed that the temperature of a water at the bottom of a beaker has decreased. Here you have to explain evaporation. What happened, like there's a beaker which is filled with water and a student placed a thermometer. So a thermometer is placed here. So when like be below the air, what will happen? That the increases, the most energetic particles will start to escape. So as most energetic particle will start to escape, so the particles which are left behind, the particles which are, yes, you can mention convection, but mainly it is like evaporation. Like most energetic molecules escape, so the particle which are left behind will have low energy. That's why the temperature decreases. So most energetic particles, that is 1 mark. At the surface, that is another mark. Like at the surface escape. And the last thing, because how it cooled down, so the particles left behind have low energy. Convection, normally when we use a convection is for when we are supplying the heat energy. Like if I say I supply the heat energy from the bottom and the substance, the gas escape or it turn into vapor, that time you will use a convection. Like and particles gain energy, density become low and they rise. But we are not supplying energy, we are just blowing the air over the surface. So we are causing evaporation. Is it clear?
Yes.
Yes, sir, clear.
The next is, this was page 10. Next is page 11, 13b. Figure 5.2 shows a volume of a gas. A piston in the gas is cylinder is free to move. The piston moves to the left. The temperature does not change. State in terms of molecule what happened. So if I reduce this spacing, I move toward left. So what will happen to the pressure? The pressure will increase. It's a 4 marks. So how you score the 4 marks? First thing you will mention, like when we move, there will be more collision, the pressure increases, the volume decrease, the particles will come closer to each other. 1 mark, first, the spacing decrease, the volume decrease. And why the volume decrease? Because the particles come closer to each other. Or you can also mention the density increases. Then second thing, the pressure increase. And why the pressure will increase? Because more collisions will happen or more collision will occur between the particles. Yeah, you can mention volume contract or volume decrease is the same thing. But why volume decreases? Because we have to explain in terms of molecule. So the particles will come closer to each other. That's why the volume is decreasing. And then why the pressure increases? There will be more frequent collision or more collision. That's why the pressure is increasing. So this was page 11. Then we have page 12, question 14c. In third experiment, the same initial amount of a cold water is poured into a metal bowl. The metal bowl has the same shape, same size. Compare the experiment. A, the decreased temperature is less in same time. Why? First, it was in experiment, a cold water is poured insulating material. So we have to compare with experiment A, the decrease in temperature is less in the same time. So two bowls are there. One is made from insulating material and another like this was insulating and this one is a metal. And we took the same, they have the same shape, they have the same surface area, same amount of the liquid is used. Like the amount of liquid which was used on insulating bowl was same as an amount of liquid which was used in a metal. So the question is why for a metal the decrease in temperature is less. Like example, for a same time interval, when I say we started this, both were having 20 degrees, the water is 20. But after 5 minutes, the insulating might have 15. It practically it's not possible for to be have 15, but I just take a value 15. But for a metal example, it might be 18. Why for a metal there's a smaller change in temperature as compared to that of liquid in metal have a smaller change in temperature as compared to insulating material. The reason is that because metals are good conductor of heat energy. So metal can take energy from the surrounding and absorb energy from surrounding, and that it can transfer to the liquid. That's why the liquid temperature won't be very low. So 2 marks. One is for metals are good conductor of heat energy. And the second thing, the heat transfer from surrounding to metal to water. That's why the water temperature might not be very low. Because the insulator is not absorbing any energy from surrounding. Like in the surrounding, there is no energy. Why it is practically not possible to 15? Because the temperature evaporation is a slow process. So if I say 5 minutes, the temperature decrease by 5, it's practically impossible because of evaporation. Evaporation is a very slow process. So this is not absorbing any energy from the surrounding, but a metal absorb energy from surrounding and then it transferred to the liquid. That's why the liquid temperature is relatively higher as compared to in an insulating bowl. Next is page 14. Page 14, question 19b. The first is we are supplying the heat energy. So first, when we supply the heat energy, what will happen? The flask will expand. So when the first, because of directly the heat is transferred to the flask. So when the flask is absorbing energy, flask will expand. And when the flask will expand, what will happen to the level here? This level will decrease because the flask size has increased as first it is absorbing energy. So size of the flask will increase. As a result, what will happen? The liquid will move down. So why at first the level of the liquid will fall in the tube? The flask absorb energy from the source. The flask expand, and that's why the level of the liquid decrease. Then why the level of the liquid in the tube stop falling and start to rise? Then what will happen? Now the energy transfer from flask to a liquid, and when liquid expand, a liquid absorb energy, liquid will start to expand. And when liquid expand, expansion of the liquid is more. That's why it will rise more. So first, why it fall? The level fall because like first you were having a flask, you supply heat energy, the flask expand. So as a result, when the flask expand, the level, what you will observe, the level, it won't be same, it will decrease. And then why the level increases? Because now the flask is transferring energy to the liquid. So the liquid expand and that's why the level is increasing. Why expansion more in a gas? Because gas, the particles are far from each other and they have a very weak attraction between the particles. Gases expand more than liquid and liquid expand more than solid. And why the liquid level is in the tube stop falling and start to rise? That's the same I've just mentioned. The next is page 16. Page 16, question 21A. 21A. So this experiment shows the identical metal plates are there. Front one is a dull black, another one is a shiny. State the additional apparatus what we need. We want to compare. The experiment is which is a good place best emitter. So how we can identify which is the best emitter? So we need a thermometer. We have to measure their temp because and the one which is best emitter is also a best absorber, good absorber. So we need a thermometer for this. Without thermometer, we cannot identify. Like we have to measure a temperature. So additional apparatus want what we need. We need a thermometer. The next is one precaution for ensuring a fair comparison. How we can make a fair comparison? We should heat them for the same time. They should have the same surface area, same distance from the source, same type of a heating coil should be used in the heater. Like the same type of same time the heater, like there's a heater inside. We supply heat energy, they both become warm, and then we record the temperature. The one which is a good emitter, or the if you use a thermometer here, like measure a temperature for this one, so we should place a thermometer from equal distance from both of them. Yeah, same amount of heat supplied, or same initial temperature you can also mention. State the result you expect. We expect dull and dark surface to be a good emitter, and write down name of heat radiation, what we call heat radiation. That we'll discuss in electromagnetic spectrum, the block 3. Heat radiations are also known as infrared radiation. Next, page 17. Page 17, question 22B. 22B. Figure 5.2 shows the path of few molecules leaving the surface of a liquid below the boiling point. So means evaporation happen. State which liquid molecule are most likely to leave the surface. So which liquid molecule, most energetic molecules are likely to leave the surface. And what is the reason why the most energetic molecules likely to leave the surface? Because they have a greater amount of energy, so they can overcome the force of attraction. So which molecules likely to leave? The most energetic. Means the molecules which have the higher energy, they can leave the surface. And explain your answer, because most energetic molecules have high energy, so they can break the intermolecular force. No, molecules are at the surface, but in evaporation, molecule at the surface escape, but not all molecules at the surface escape. Which molecules at the surface will escape? Those molecules which have very high energy. So it's not like all molecules at the surface escape. Only those molecules which have high energy can escape. So most energetic, like the molecule here is escaping, but molecule here does not escape. Why? Because this molecule have a high energy. So molecule here escaping, molecule here escape, molecule here does not escape. Why? Because it has low energy. So most energetic molecules will escape. And why they can escape? Because they have high energy, they can break the intermolecular force, and they can do a work done against the force which resists their motion. That's why they can escape. So why? So the second one is of 2 marks. Like they have more force, they have more energy, so they can easily break the bonds. Is it clear, this one?
Yes.
Then the last doubt is question page 21, question 25B2. 21, 5B2. Question 20, this one. Look, this is the old way of keeping the things cold. In a space where refrigeration is not possible, a person attempt to keep a bottle of a milk cool by using a procedure illustrated in figure 7.2. A bowl is there which is filled with the water, a bottle of a milk, and a damp cloth is there. This is what it's not, it's a very common thing. Like in case of a heat wave, or when the temperature is too high, what people used to do, they take a wet cloth and they kept it on a forehead. What is the reason for that? Or even if a person is having a high fever, so a moist or a damp cloth is used to reduce the body temperature. What is the advantage of that? Basically what happened, these particles in the damp cloth, the water particles will absorb energy from their neighbor, like from surrounding. And what is a neighbor for them? For them, it's a bottle of the milk is a neighbor. So most energetic molecules of water absorb energy from its neighbor, from its surrounding and escape. As a result, when these water molecules will escape, so this bottle of the milk will remain cold. It's not like it will be refrigerated. It will not be in a negative, but it will have a temperature like a very low temperature, which will not allow the bacteria to grow, or the rate of growth of a bacteria will be very slow. So how you get 3 marks, explain in terms of molecule, why, how this procedure is successful, or how this procedure will have 1 mark. The most energetic molecules at the surface will escape. So the molecule, and so the first 1 mark is for water evaporates from the cloth, or most energetic molecules escape. So molecules which are left behind, and these most energetic molecule absorb energy from the surrounding, or they will absorb energy from the bottle of the milk. So the molecules which are left behind will have low energy. So the bottle of the milk temperature will decrease. And why the third mark is there? Third mark, why it is always placed in a bowl of a water, so that when the water molecules escape, other molecules can so enter this cloth, and they will start, like it will be a continuous process. Otherwise, if you just place a damp cloth, when all of the water evaporates, there will be no evaporation. So the process will stop. So to make this process continuous, that's why we place it in a bowl of a water. So the 3 mark, 1 mark, most energetic molecules escape, absorbing energy from the surrounding, leaving behind the second mark, leaving behind the less energetic molecules. That's how the bottle of the milk will remain cold, because the surrounding is cold. And the container, the why the cloth is in the bowl of a water, to make this evaporation continuous process. Is it clear, this one?
Yes, sure, Jazakallah.
Any other question or doubt? Anyone else having a question or doubt from this exercise? Because not all the students, they send the homework, but they do not mention the doubt. So anyone else having a doubt or a question? Any page? No doubt? Okay, so